Welcome to third normal form. A relation is in third normal form if and only if it is in second normal form and there is no transitive dependency for non-prime attributes. Now take this relation for example. So I have ID which determines name, zip, state and city. Do you think this is a good table design? Take a minute, pause the video and have a look. Well, if the functional dependencies ID determining zip and zip determining state and city are given to you, then this certainly is not a good design. Why? Because I understand that ID determines zip and zip determines state and city. So that means there are unique values of states and cities for a given zip. Now this causes update anomalies, so we don't like this kind of table design. So in other words, wherever there is a repetition of zip, I have to ensure that the state and city are properly updated or properly inserted into this table, right? So this causes redundancy as well as anomalies. So how do we fix this table design? Here is a solution. So I can split it into two tables. In the first table, I may have ID, name, and zip. And in the second table, I could have zip, state, and city. And here I could make zip uh, as the key. Okay. Now, if you notice, we can say that for every functional dependency x to y, at least one of the following conditions should hold, right? So either x is a super key. So now in this revised table structure, there are two dependencies, id to name and zip. That's one dependency which holds on this table, and zip to state and city which holds on this table. In both the cases, um, if you write zip to state comma y, then x, which is the LHS of the functional dependency, is a super key. So that way, the first condition holds, and we say that this table design is in the third normal form. Now let's go back and look at these dependencies. So for every functional dependency, we check whether the LHS is a super key, right? So LHS is a super key. So this functional dependency is all right. And so there are non-prime attributes here. So zip is a non-prime attribute here. So for non-prime attributes, we don't want any transitive dependencies, right? So now for this zip, there is a transitive dependency. ID determines zip and zip determines state, for instance. So this can be detected using this rule. So after you have broken down into third normal form, or if the given schema is already in third normal form, then for every functional dependency, either x is a super key or y is a prime attribute. Now here we see that none of these are prime attributes and x is not a super key. So this table does not belong to third normal form, or in other words, we can say that there is a transitive dependency here. So you could use this condition to determine whether a given table is in a third normal form or not. So let's take an example to understand this. So let's say I give you a relation R with attributes A, B, C, and D, and these functional dependencies are also given to you. AB determines C, ABD determines C, ABC determines D, and AC determines D. Okay, so let me first start by asking you, what is the key here? Can you figure out the key? How do you find the key? Well, for every attribute, you determine the closure, and if a single attribute is insufficient to cover all the attributes, then you start adding more attributes and see if you, so such keys are what we call as composite keys. So you start looking for composite keys with more than one attributes, right? So let's first work out what is the key, and once we have the candidate keys, then we know the prime attributes. And once we know the prime attributes, we can apply this rule for every functional dependency. So for every functional dependency, so this is the first functional dependency, the second functional dependency, and so for every functional dependency, we check whether X is a super key or Y is a prime attribute. So either X should be a super key or Y should be a prime attribute. Okay, so that's what we want to check, and if that turns out to be the case, then it's in third normal form. Otherwise we say it's not in third normal form. Once again, pause the video here and work it out yourself to see if you understood correctly. So here is the answer. AB forms the key here. So from AB I can determine C, and with ABC I can determine D. So pretty much AB determines everything else. So AB is the key. So the prime attributes are A and B. Okay. Now we have everything that we need to test for third normal form. So let's take all the dependencies. So we have AB to C, ABD to C, ABC to D, and AC to D. So there are 4 functional dependencies given here. So we take all these 4 functional dependencies and ask, is LHS a key, right? So let me show you the conditions once again. So for every functional dependency, either X is a super key or Y is a prime attribute. So here if you look at it, LHS is AB, so LHS is a key for all these 3 functional dependencies. So let's take the last functional dependency where AC to D is the dependency. AC is not a super key. So if AC is not a super key, then we expect D to be a prime attribute. But D is also not a prime attribute. Since D is also not a prime attribute, we can spot transitive dependency here. So R is not in third normal form. Okay, now you may ask, where is the transitive dependency? Can you find out the transitive dependency here in this functional dependency? Once again, pause the video here and work it out for yourself. Thank you.